Ah, the warm feel of a hairdryer in the morning. Just warms your whole body up. But we've all seen it in the movies. Somebody tosses an electric hairdryer in the bathtub and zap! Can a hairdryer still electrocute you? We'll find out when we compare a modern one to one our parents used back in the 60s.
Our first test, a 1960s model hairdryer with 380 watts of power.
It's plugged in, it's live. We're gonna drop this in a tub of water and see if it would actually electrocute somebody. Do you know what's gonna happen? I have no clue. Absolutely nothing. I expected flames, spark, and mayhem, but nothing happened. I know I still have electricity running to it, so I've got a voltmeter. Let's test this water. Wow. Oh my. 46 volts of electricity is running through this water right now. That would kill you. Let's cut the power to this hairdryer and now try our modern version, see if we get different results.
A modern hairdryer, 2 blower speeds and nearly 2,000 watts of power, 5 times more than a vintage hairdryer.
Well, feels good. All we can do is drop it into a bathtub full of water and see what happens. Okay. I'm going to pull my voltmeter back out and see how much electricity is inside of our tub. Remember, our 1960 model provided 46 volts. Very interesting. 0 volts of electricity in this bathtub. And this is no joke. This is live. Now don't try this at home, but I've tested it with a voltmeter. No electricity in this bathtub, and I'm going to prove it. No glove, bare hand, in the water. Ah! Did I get you? This modern day hairdryer possibly could have saved your life. This 1960s model hairdryer charged our bathtub up to 46 volts. The new ones, though, a lot safer. Time to slice them open and find some answers.
John, for this cut, the Omni DualSaw counter-rotating blades.
The Omni DualSaw has 2 blades running in opposite directions, typically used for smaller cuts because the 2 blades create less kickback.
Feels powerful. And as we peel back the layers, we reveal a very simple mechanism. As this fan draws air from the back, it goes over these hot coils and out to the front, drying your hair. But I see nothing inside that would prevent you from being electrocuted. Let's look at the electrical cord, and you can see there's nothing different here as well. Our new hair dryer. Must be some safety protocols built into this. Let's slice it open and find out. Definitely high-grade plastic. Look at that. It looks almost identical inside to our 1960s version, but with a lot of improvements. A lot larger fan, quieter motor, and insulation to keep the outer shell from heating up so you can touch it and not burn your hands. But I do not see anything inside of here that would keep you from being electrocuted if it fell in a bathtub. Let's check out the wire. If we follow this down to the plug, looky here. This is very much different than our 1960s model. Let's slice this open and take a look inside. Does this look a little big for this slice? It does, doesn't it?
Let's try this on for size. 35,000 RPMs when you have it on full speed.
It's like a micro slice. Look at this. This was not available in the 1960s. You just had a direct line to the electricity coming out of your outlet. This plug has a little circuit board inside of it that actually measures the amount of electricity that's going to your hair dryer.
When the new dryer is dropped in the tub, the electricity flows into the water, creating a sudden increase in current. Inside the plug, a tiny switch is activated that shuts off the dangerous current before you get shocked.
I'm sure there's been times when you're drying your hair and you had to reset one of these buttons and you always wondered, why is that there? Well, this is there to potentially save your life. Don't go grab your hair dryer, fill up your bathtub full of water and drop it inside to test this theory. That's my job.
Up next,
Does anybody know if the water's turned off?
I'll get into hot water
This feels really good.
and try to debunk a porcelain myth.
I know a lot of people not believing this right now.
America.